All right. Good morning, everyone. Thank you very much for joining this seminar, even though it's a bridge day today officially. However, I'm very happy that some participants have registered. Um, Anyways, I'd like to introduce our speaker for today, Mr. Andreas Schröter. He will give us very valuable information about the new Sapphire biomolecular imager, and he will show us some possible applications and how our customers, and in particular you, will be able to profit from this new technology. So thank you very much, and please welcome Andreas from Azure Biosystems.
Yeah, thank you, Florian. Hi, guys. Here's Andreas from Azure, and so Axonlab is our exclusive distribution partner in Switzerland, and all Azure products you can get from Axonlab. Yeah. Well, I'm really happy that we can present you today our Sapphire biomolecular imager. So we placed this machine recently also in Switzerland. So it's also here at the ETH Zurich. And by the way, we have today also a next demonstration of the unit today, and hope also to have a second unit soon at the ETH. So the Sapphire biomolecular imager, we put the machine on the market end of 2018. So it's a brand new, fresh unit. And before I tell you what's possible with this machine, I would like to give you some brief introduction words on our company itself. So Azure Biosystems is a company from the US. We are manufacturing engineer of San Francisco, quite close also to the Silicon Valley, but you will get the local support from Axonlab in Switzerland. Yeah. And also I am by myself responsible for Germany, Switzerland, Austria. So you will get also my support in this territory. Yes, so what I want to tell you, so we have a lot of innovation in our company. So this is our VP of Research and Development, Deeping. And Deeping was the 20th employee of Illumina. Yeah. So he brings a lot of innovation into the company itself. And by the way, he was also one of the guys who invented the fluorescent Western blot together with Alpha Innotech. Yeah. So he was also the VP of Research and Development at Alpha Innotech. So when we take this into account, we have over 25 years of evolution together with the machines from Alpha Innotech. It started with 1995, and the Azure brand itself, we put it on the market 2013. So we started with the focus on camera-based systems, and end of 2018 we launched a scanner-based system. Right now we have over 10,000 users globally, around about 700 in Europe, and around about 2,000 machines worldwide. So it's increasing rapidly. We have satisfied clients worldwide. And why we brought the Sapphire scanner on the market? Well, so we thought we have to give you a machine with really more resolution, more possible applications, more value itself. And this is the background of our company. So we are designing machines which can be used for multiple applications. The Sapphire scanner it's a all-in-one machine. Yeah, so it has RGB lasers inside, it has near-infrared lasers inside. It can do as well phosphor imaging and chemiluminescence. So you are quite flexible on the applications itself. When we look at the lasers, so we have 3 lasers for RGB, blue, green, and red, and for the near-infrared, this 2 ones, the 658 and 785. And the unique about the machine is that we have 3 detectors included. So this you will not find on the market as well. So we have the phosphor multiplier tube included, avalanche photodiode, and a CCD camera. And we have, of course, we put also on this technology 3 detectors in one machine, a patent pending in US, and we will also put it in Europe soon. The phosphor multiplier tube is used for photoimaging and the blue laser. And why? Because the phosphor multiplier tube gives you a higher quantum efficiency in the shorter wave. Okay. And for phosphor imaging, you can of course use the cassette and the phosphor screen you have already in your lab. Fully comparable, possible to put it in our machine. And the only thing is the limitation. The field of view is 25 by 25. So when your phosphor screens are 25 by 25 or smaller, they will fit perfectly on the Sapphire scanner. The avalanche photodiode is used for red, green, and the near infrared. And why? Because the avalanche photodiode has a higher quantum efficiency in the longer waves. Yeah? The wavelengths which are more shifted to the near infrared. For chemiluminescence, because this is also a possibility and an application you can do on the Sapphire scanner. We have built in a true CCD camera, yeah? So it's below the glass surface, and you can do really true chemiluminescence imaging. And here we have a cool feature. So we have also a color marker feature. So when you have on your chemiluminescence plot a colorful marker, the CCD camera would make a white light picture of it, and we can mark it and exactly paste it in your chemiluminescence image. Yeah, so it's exactly in the right position then. As I told you already, so the field of view of the Sapphire is 25 by 28 centimeters, so quite large. You can put 2D gels, for instance, on it. For chemiluminescence, it's a bit smaller. It's 16 by 30, yeah, which you can use. And the special thing about the Sapphire as well is that we have a super high resolution. So we are talking here about up to 10 micron resolution, and this is very high. With 10 micron, you can even see cells. Yeah, this is possible when they are large enough. I will show you for examples later. Into the package, you can choose the computer you want. So we have a laptop possibility or high performance desktop computer. And of course, the capture software is included into the package. And this is how the capture software looks. So, I mean, it's quite convenient, quite easy to use. You just mark the area of interest. Yeah, we run a preview. You can adjust the laser power and run a final scan with the resolution of your choice. So the capture software, I tell you, really just 5 minutes in front of it, and you know everything. Quite easy and convenient for them. Also, you can choose to have in the package our analysis software. We call it Azure Spot. But we are not forcing you to use it. So we have not an own data format that you have to use our analysis software. We have uncompressed TIFF files. So the machine is generating them, uncompressed one. And we give you this file, and you can decide what you do with it. If you want to put it in ImageJ, it's fine. If you want to use a more professional software like our Azure Spot, this is also possible. And the software has some cool features like also the area analysis or colony counting. All this is possible. And of course, the classic 1D gel and Western blot analysis. So I personally think the outstanding specs here of the Sapphire are the flexibility. First, it's that you can choose for your needs. So for instance, some people just need RGB lasers for, let's say, 2D joules, or people who just want to do Western blotting with near infrared. Also for them, we have this possibility to have a version with just lasers they need. Or when you need a full equipped one, RGB lasers and near infrared, this is also possible. And as an add-on, you can choose the chemiluminescence module and the phosphoimagery module. So as I told you, the resolution is high. It's 10 microns, but not only the resolution, it's also the scan speed. So all machines can use all 4 lasers simultaneously, and this is why it is so fast, why it can scan so fast. And now I would like to talk a bit about performance and applications on the machine. So maybe you have seen so far that people are now switching from chemiluminescence to fluorescence, which is indeed first a good idea because fluorescence gives a more robust signal. You can do a better quantification, but still there are some experiments and needs where I would say I would still use chemiluminescence. So I give you an example. When you have a complex protein mixture, you want to know the detection limit. I want to know if my proteins of interest there inside. I would still use chemi. And this is why we choose to put both technologies into the scanner. You can do chemiluminescence with our machine and also fluorescence. Okay. So at the end, I think the combination of both will be is the best choice right now on the market. Yes, this I told already that the chemiluminescence has a better detection limit, but the fluorescence, as you know, we can do better quantification. It's more stable, it's more robust, and we can also do multiplexing, which is not possible with the chemiluminescence. So this is a great benefit of fluorescence Western blotting. And for instance, what a lot of people are doing also right now, they use the near infrared laser for their protein of interest. So let's say 2 proteins of interest of one membrane, and then RGB laser for total protein normalization. I will talk about later more in detail about it. In total, you can have maximum with our scanner 4 channels, as we have 4 lasers. You can have generate a file with 4 channels and have also Western blot with 4 signals. Yeah. But the most people in the field are just using 2 or 3. Yeah. But 4 is also possible. Here, just 2 examples from some of our demos. So you see here 700 and 800 nanometer signal from a Western blot. In the lower part is the merge. What we can also do with the machine, of course, to put this into black and white. So you see it here separated, 700 and 800. Here's another example, 700 and 800. Here's the merge, and here are the black and white images. So sometimes it makes indeed sense to look at the black and white images because simply the human eye can see the black and white contrast a bit better than a colorful image. This is also a topic, so you can imagine when we have a scanner with a high resolution like 10 microns, so 2D Deutsch becomes interesting. So as you know, 2D Deutsch is a possibility to run study to identify differential express proteins. And when we are using the full power of the Sapphire and scan this with 10 microns, I mean, then you will see little tiny spots, and this makes this technique at the end more powerful because you get more candidate proteins. This is also possible. So everybody is talking about this, but nobody is doing this. As I have seen so far, but right now we can do this with our machine. So inside Western, we have also an application node on it, and it's working quite good. So you can use your 96 watt plate and do inside Western from the Phosphoimaging is still a topic. You would be surprised. So there are a lot of labs that are still using it. And this is why we put also the nodule for phosphoimaging into the Sapphire scanner. We have a quite dynamic range here, as you can see. Also several application notes which you can download from our website. Here's an example from one of our last demos. So the phosphoimaging Western blot from one of our clients, scanned with 100 micrometers resolution. We have also accessories. So for phosphoimaging, this is a new accessory. We have also a eraser. So when you would like to erase your phosphoimaging screen, you can put it inside, and it's also quite convenient to use. Just 10 to 20 minutes, and the signal is erased. And it's compatible with all Azure offered phosphor screens. Yeah, so we have also in our portfolio different phosphor screens. For instance, this is an S1, a multi-purpose screen. We have also a high-resolution screen and a tritium one for high sensitivity. Yeah. You can get also the cassette from us as well. Okay, and now I would like to give you just, let's say, examples from our demos, and also I will give you right now a slideshow of, let's say, scientific and some non-scientific images. Yeah, so see these images like a proof of concept. Yeah, what is possible with the machine itself. Let's start with this. This was one of the first images I imaged on the Sapphire. Yeah, I put one of my old samples from my lab on the scanner. This is a red brain frozen, dried. So of course the quality of the sample here not the best because dried. But anyway, you see it here in different channels. So I think it looks quite good. Yeah, and on a request of one of our clients, we put also some thick tissue samples on the scanner. So we scanned for one of our clients sheep tongue, and to get fast image, we stained it with Comessi, okay, to enhance the autofluorescence. So this you can always do when you have tissue. You can stain it with Comessi, destain it with water, and then you have a massive autofluorescence signal to give you a first hint how it could look like with secondary. So here are the images. This is from the front side, the sheep tongue. I just will skip through the channels. Yeah. I also can zoom in that you see the details a bit more. And now I show you this from the back side. It's scanned with 10 microns, so the full resolution of our scanner. You see it here in different channels. You can also zoom in to see the structures of the tank. Even you see here how we cut it through the muscle on the left. Yes, this was another application. So we put for a client a cow stomach on the scanner. Also here, same procedure. We stained it with Comessi, destain it to enhance the autofluorescence. And look at this. So I personally think this is one of the best images. We really like microscopic quality. Right? You see here the cells enlarging the surface. That's really great. So I just click here through the channels. And by the way, of course, this are pseudo colors. Yeah? You can always choose channel by channel which color you would like to have, and design it in a way at the end how you would like to see it. This is one of the last demos we had was in an institute in Vienna. So they're interested in plant research. They're doing a lot with Arabidopsis. And you can see here the protein of interest is red. This red signals on the top of the leaf, and green is the chlorophyll. Then we had also some high resolution scans of the roots of Arabidopsis. This is also scanned with 10 microns. and we see how detailed this is. Yeah. This was also very interesting. So the guys had this Arabidopsis plants in a dish with a culture medium, I think was some kind of agar-agar. But anyway, we put this dish on a sapphire and you see it here from the bottom. So the roots which are growing into the media itself, and then on top are the plants. One of our first clients of the Sapphire is from Germany in Bonn. So they were looking for a microarray reader. Yeah. So and we give them the chance to try our machine because we have a larger field of view than the standard microarray reader. And here you see the results. So the site itself is like a microscopic slide. Yeah, I hope that you can see it. Still refreshing. Okay, I think now the images are there. So you see it here. These are 3,800 spots on this microarray. Yeah, you see it in a black and white level. I can even zoom in at this part here in the middle, and you see it's perfect. Yeah, so the resolution 10 micron is here more than enough for quantification. And at the end, the client decided to go with the Sapphire because just the flexibility is stronger than just a normal microarray reader. We have 25 by 25 centimeters field of view. So you can imagine you can put the whole surface with microarrays, scan it, and then you are finished. Yeah. Here's another one, another format that you can see, and this is a zoom in. Also, gel applications are of course possible on our Sapphire scanner. So, I don't know if you know this, the Commercy gels have a great autofluorescence with 700 near-infrared. So you could also put your Commercy gels on it and do quantitative Commercy on the Sapphire. That's possible. We can have also silver gels on the Sapphire, but this is image done with the CCD camera. And if you would like to have DNA gels, also this is possible, but of course nobody would like to put on a scanner like this ethylene bromide gels. By the way, this is possible, but of course you would never do this in your lab. So you can use also safety dyes. Yeah? And this example is was an old Midori green gel from one of our clients we found in the bin, by the way, but we put it in buffer once again and look at this. So it was already great result for this old Midori green gel. We recently also placed a machine at the university in Amsterdam, yeah, in Netherlands, and this guy are working with tissue, and for them it was important to look also in different layers of the tissue itself. And one of our benefits of the Sapphire scanner is also that we can move the scanning head up and down. We can move it 4 millimeters up and down, and this is allowing you to do kind of Z stacking. Yeah? And so the guys here are using a clarity protocol. It's called iDisco. iDisco is free available. You can go to this website and follow the protocol. I think you just with reagents, and then you get rid of the fat of the tissue. So they put a cleared mouse heart on the scanner. Okay. What we have done, so we have done the images with different positions of the scanning head. At the end, we choose the best one as an overlay of the 700 and 800 channel. You can see it here. This is with 10 microns. The scanning time was here. Also a client I had in Germany, in Magdeburg, a demo also quite recently. They're doing also stuff like this, but they're using not iDisco, they're using Cubic. Cubic is also a possibility here the tissue. And they have a cool application. So they have a mouse skull, which is completely clear. This is an embryo mouse skull E16. I can zoom in, you can see it here. And this was quite interesting application. So the protein of interest is expressed in the brain of this animal, right? So we looked with the Z stacking feature in different positions, and this was the best result. I show you here the single channel, so 488, 700, 800, and this is an overlay. And what you can see here, so on the left side, this brown thing, this is the eye, and the green signals are the protein of interest, which is expressed in the brain of this animal. So quite cool application. Now I would like to give you just a few examples what so is in addition possible. So we have also some clients which are doing research on plants. Also I give you a few examples. This is corn with 20 microns on the scanner. You can see it here. When you zoom in, so you see all the details, quite sharp, very nice. And this is one of our clients had a leaf, which is expressing certain interest. And we can have also zoom in. You see here this little speckle. Yeah. And this is another one. Very detailed, very sharp, as possible with our Sapphire. So this is one of the last images I would like to show you to the end to have some fun. So we put also a dragonfly on scanner. Yeah. A really big one. Nice animal. And we scan it with full resolution. You see here the details of the wings, the eye itself, also the wings once again, and the eye. And when we zoom in, you can even see the facetta cells on the eye. Okay, so once again, to remind you, the Sapphire has three instrument modules. You can have the Sapphire RGB only version, you can have the Sapphire near infrared, or a full equipped one. And on top, if you are interested, we can build in for you chemiluminescence options, so our CCD camera, and also our phosphor imaging one. And now to the end, I would like to talk about quantification on the Sapphire. So for a quantitative approach, we have also the Sapphire, we call it Sapphire Near Infrared Q. And what is this? This is a Sapphire with a near infrared module, so 700 and 800 nanometer laser. Plus, you get the green laser. Which and why we have placed this machine? Because maybe you heard already, so a lot of people are talking about Western blotting 2.0. And what is this? This is that people are going away from normalization against standard housekeepers protein. And why are people doing this? Because you can imagine when you just rely on one protein like GAPDH and beta-actin, it really depends on the cell cycle, how high the expression is. So it's not 100% even. Yeah, this is the thing. And so at the end, the better way is to rely to put this variance, let's say, on more shoulders. So when you have a complex protein mixture, let's say 3,000 proteins, it's better to say, let's do the normalization against total proteins, all proteins which are included into your mixture. Okay, so this is Western blotting 2.0. And there are a lot of publications out there which are discussing the benefit and that it indeed makes sense to have a total protein normalization. So for total protein normalization, we have a stain which is called Azure. So Azure is reversible. So if you want to do mass spec afterwards, it's possible. It will stain all your proteins with a very good dynamic range and a very good linearity over 4 orders of magnitude. And the dynamic range is here very important for protein staining. And why? Because as you know, the most complex protein mixtures have high abundant proteins, but of course the low abundant ones are also important, right? So you need a stain which is staining all of them, and this is why you need a high dynamic range. And you can see it here in the comparison with Kumes on the right part here of the slide. So stained with Kumersi, we were able to detect here, I think, 3 or 4 bands, and with Azure Red, the same sample, we see much more. So it's very good for topic protein normalization. So once again, Sapphire and infrared, choose the QU model, and then you are ready for Western blot 2.0. And that's it. I'm end to end, and I would thank you for attention and open it for your questions.
Thank you very much, Andreas, for this really interesting presentation, and of course for the amazing pictures. From my point of view, in particular, the possibility to combine a broad range of different applications within one instrument really adds value to our customers. And first of all, because you will need less space, you can save money by only buying one instrument instead of 4. And of course, the quality of the pictures, as said, is simply amazing. So I hope the presentation was helpful for you. And please don't hesitate to get in touch with your Axonlab sales account manager. You can also check out our website, www.axonlab.ch, in order to retrieve further information. And of course, you can also check the Azure website directly. You will find a lot of information about the different machines and application notes. So now I think it's the right point of time to open the discussion. I think our administrator can now unmute you, or you can simply type your question into the chat box. I think we've already received one question from Ms. Rudai. She's asking, where in Europe has Azure installed instruments already? So I guess she's talking about reference customers. Andreas, do you know?
Yes, sure. Yeah, so in Europe, indeed, we have already several machines. I mean, I can speak for my territory. So in Germany right now, we have 4 machines placed. A 5th is now in the pipeline to be placed, and we have. So I think by end of the year we will have 10 machines in Germany. In Switzerland itself, we have already one here at the ETH Zurich. And today, as I told you, we have the second demo, so we hope to place a second at the ETH Zurich soon. So here at the ETH, the first one we placed is at the lab of Professor Simone Schürle. And in Austria, we have also one machine at the EMP in Vienna. And in Germany, it's right now it's WKFZ in Heidelberg. We have one in Mainz. We have also one at the Ruhr University. Yeah, and also in Bonn. Yeah. And over Europe, in Denmark, we placed recently, I think, 3 machines. So it's really increasing right now, very fast.
Thank you very much, Andreas. Are there further questions? I think we're about to receive another comment or question from Ms. Rudai. Here we go. She's asking, how would you describe the typical Sapphire user?
Oh yeah, that's a good question. Well, the typical Sapphire user, yeah, I mean, you can imagine people who are using the Sapphire are, of course, doing Western blot. Yeah, so I would say the typical Sapphire user is doing 50% Western blot and 50% an additional fluorescent application on top. Yeah, this could be like tissue imaging. This could be microarray. This could be 2D dyes, whatever. But the core application is for sure Western blotting, 50%. Mixed with additional fluorescent applications.
Thank you very much, Andreas. Are there any further questions? Maybe let's wait for a couple of seconds. Well, if there are no further questions, I think we can close the webinar now. However, as said, please don't ever hesitate to contact us. You can ask your questions after the webinar by email. You can call us. If you like, we can also send the recorded webinar to you by email, so you can have a look at it afterwards again. Yeah, and last but not least, thank you very much for your attention and hope to hear from you soon. And I wish you a very nice weekend, of course. Thank you very much and bye-bye.
Thank you. Bye.